You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Haqq-Misra. Haqq-Misra is a senior research investigator at the Blue Marble Space Institute of Science. As a member of the American Geophysical Union and the International Astronomical Union, his research focuses on understanding the conditions that allow life to survive on Earth and the possibility of detecting signatures of biology or technology on other planets. He also studies the possible futures of life in the solar system. He received his PhD in meteorology and astrobiology in 2010 and his MS in meteorology in 2007 from Penn State University. He is joined by Thomas Fauchez. Thomas Fauchez is a space research scientist employed at the American University at NASA. His research interests involve the modeling of exoplanetary atmospheres, climate, and circulation using general circulation models, with a particular emphasis on clouds. He also employs radiative transfer tools such as the Planetary Spectrum Generator to simulate atmospheric characterization of rocky exoplanets and biosignature detection with future space-based observatories. He is also interested in the climate and forecast simulation of Mars to develop a global forecast system that would help future NASA Mars missions. Remember to subscribe to Event Horizon so you never miss an episode.
Haqq-Misra and Thomas Fauchez, welcome to the program.
Yeah, thanks for having us.
Thank you.
Gentlemen, you've both been party to two recent papers regarding the detection of alien technosignatures, far or near. And my question for you to start is, all right, so what are the likelihoods of seeing a close technosignature, such as within the solar system, versus seeing a very distant one out in the galaxy somewhere light years away? Is it more likely that we would see a detection of alien life very far out as opposed to very near, or are the odds about the same?
You know, for me, I don't think we can say anything about the odds. I think we have very little searching that's actually been done. And we don't know anything about alien life. We don't know how common it is, how rare it is. We can get into talking about the Fermi paradox. All we can say is we know there's not spaceships flying around the solar system every which way that they're so obvious that we see them. That's pretty much all we can say. Is you can rule out some of those extreme sci-fi scenarios of like a galactic club in some level, but not much more. So I don't know. We might find technosignatures with James Webb. We might find something on Mars. I don't really think we have a likelihood.
Yeah, I agree with Jacob. I mean, it's we don't have data so far, so we need to completely, to stay open on the question. And same goes for the biosignatures. Actually, as Jacob just mentioned, we may find, first sign of biosignature on a very distant exoplanets, or maybe we will find some on Mars. So it's very hard to tell right now.
In the past, if an alien civilization had visited Earth, and we have to bear in mind that Earth is 4.5 billion years old, and throughout that entire time, somebody could have visited in the very distant past, do we have much of a hope of finding any evidence of their visit?
Well, it depends on where they visited and what they did. So if you visited Earth, the surface of Earth is very active. Things get resurfaced really fast. And so even if there was some artifact on Earth that some visitors had left, it might be really difficult to find. It might have already gotten bound up in other processes, geologic processes, if that was a long time ago. If it was on the moon, maybe you have a better chance at finding something that's been left there, maybe an artifact, maybe waste, because the moon is a more serene environment and things are left undisturbed there. So I think it just depends on what activities they were up to.
Yeah, absolutely. I mean, there is this interesting paper by David Schmidt and Adam Frank about the Silurian hypothesis. We were like, would it be possible to detect industrial civilization in the geological record? And so that was a very interesting paper a few years ago. And that's not that easy, actually, because geological processes can really resurface a lot of things and can be also an open question. I think maybe the only thing we may be able to find would be like a very high density of heavy metals and things like that. that could be a clue. But otherwise, yeah, we on the scale of 100 of million or billion of years, we can really have everything completely erased.
What is, in ideal conditions, and let's set aside the idea of space travel, that it would be much harder to go and search some Kuiper Belt object or something like that for a technosignature versus searching the moon. What is the ideal environment for preservation of an alien artifact within our solar system? Where could we go and say that's the best place to look?
That's a good question. Tomas, if you have any ideas, go for it.
Yeah, it's a tough one indeed. I mean, I will say a place where we have a lot of data, at least because we are really data driven. You know, of course, on Earth, we have a lot of satellites, we have a lot of observation. But even like for the moon and Mars, we have many orbiters and instruments. That could be a nice place. And there is no anymore, drastic change on their surface. And so I would say, yeah, it could be a place where you have a combination of a lot of instruments, a lot of data, and also something that is not, changing all the time. Like on Venus will be extremely challenging, for instance, or Titan, you can change also very quickly. So yeah.
Yeah, I think I agree with that. Maybe I would add, you could look, if you're looking for free-floating artifacts, maybe some of these stable Lagrange points. So there's stable points in orbits between two bodies where objects, debris, asteroids will kind of trail along with the planetary body. So that might be where some alien probe that's no longer working ends up, or maybe it's a place to just observe us. Whatever its mission is, if it's an alien probe, you can kind of park there with low energy costs. So that could be a place to look.
In regards to placing objects that somebody could discover, we've done this. We've stuck gold records on the side of spacecraft, and we've sent out at least one powerful signal, from Arecibo to try to get the attention of aliens, although it was half-hearted. Now, if an alien civilization wanted to say, look, we visited here 10 million years ago, is there a natural place where they would put an object, just like the hydrogen line, where we speculate, well, maybe they would put a signal here? Is there a natural place in the solar system where an alien civilization would put an artifact intentionally with the intent of it being discovered?
So this is like 2001 Space Odyssey, like where do you hide the monoliths? I don't know. That's a great question, because then you're getting into alien sociology. Like, what would they think would be a good idea? We can speculate what we would do if we were trying to get that attention. But if you're talking about some alien civilization that's possibly more advanced than us because they had interstellar travel capabilities, I mean, it's a guessing game as far as I'm concerned. Like, I don't know. Like Tomas just mentioned, every place in the solar system has some lifetime at which things get resurfaced, and there's environmental processes that can weather things and make them difficult to last. So it's a dynamic environment. If you're talking about someone who visited 5 billion years ago and you wanted something to last that long, I actually don't know what could last that long. I'm sure there's something, but I would just be guessing, really.
Yeah, I will put it probably on the moon because it's super close. I mean, we have been there, we are going to be back, and there is not really a lot of change on the moon's surface. I mean, you have still some craters that are changing, but most of the surface remain the same. And so, yeah, I think it would be a combination of being easily reachable and also not changing too much. So I think the moon may be the best place for that.
Now, say we decide as a civilization, whether intentionally or just as a byproduct of us exploring the solar system, say we decided to stick a piece of concrete on the moon, big concrete block, rebar concrete, and bury it. How long would it last, and how would an alien civilization find it as a technosignature?
Yeah, that's a good question. That's a little out of my technical expertise, but I mean, I think there's a cratering rate of the moon. Now it's slowed down since earlier times, but there's still impacts. So over time, the moon will get hit by things. But I mean that might vaporize some of it, depending on how big the impactor is. You might just send some of the concrete up and scatter it, making it harder to detect. It's gonna last, maybe on the order of millions of years, but probably not billions of years. So things can stick around for a while, but when you're talking astronomical time scales, when you get into the billions, things inevitably change.
That would be the ultimate and tragic if an alien civilization visited us 2 billion years ago, left an artifact, and it was obliterated by an asteroid, and we never know about it. So it drives home the point that the universe is very dynamic and that nothing is forever. Now, let me ask you guys this, and I want each of your views on it. Some people will make the case that the UAP phenomenon is compelling and points towards an alien origin for these things. I don't think we're there yet myself, but I wanted to get your viewpoints on that. Is it worth looking into from the perspective of astrobiology to, try to determine if whatever people are seeing, the Navy, etc., is of alien origin?
Well, I'm interested in the study of UAP, not necessarily because of that, but I'm fully cognizant of the fact that a lot of people think that there's a connection between what astrobiologists should be caring about and this. And I can't say that there's no connection because they're unknown and we don't know. So I think in that sense, it's worth a few astrobiologists paying attention to what's going on. But you know what I've made this comment in the SETI community before. Like, I haven't seen any evidence yet to say that there is a connection between any of the UAP we're discussing now, or even any of the historic cases, that there's a connection between that and extraterrestrial activity in any state. Like, nothing, the data has not convinced me that there is a positive connection yet. But I can think of a hypothetical case in which there is a connection, where you have an alien spacecraft that's headed from Alpha Centauri into the solar system, is flying by Pluto. Well, that's a thing that SETI scientists would care about, because that's a spacecraft that's from another solar system. Well, let's say that spacecraft lands on the moon. Well, that's something that a lot of SETI scientists would care about now too. There are studies that actually consider this idea of looking for artifacts on the moon and Mars and what you would look for. So those things are fine within conventional SETI, but as soon as, if that spacecraft were then to enter Earth's atmosphere and it were to be seen by radar and video camera, you'd call it a UAP right away. And if that's off limits for SETI, then there's a problem, because even if that's not what we're seeing now, that's a hypothetical I can come up with where there is a connection. And so in that sense, we have to be paying attention. We may discover a lot of other things in the process of studying UAP that have nothing to do with aliens, but there's a hypothetical connection, so we should be able to talk about it so that we don't miss something that we're really interested in.
Yeah, I totally agree with Jacob. I mean, there should not have any taboo on that question, and every hypothesis needs to be on the table. And I think it's the best way that we are going to approach that. And you may have seen that recently NASA has built a sort of task force to try to answer those questions. And there is one actually astrobiologist in that team, David Grispoon. And so it's a very good sign.
Tomas, I have a question specifically for you. Do you find a difference? Now, we talk about taboos, as was just mentioned. Do you find a difference between the taboo in the United States versus France? Are the attitudes different regarding the question of UAP?
That's interesting. So we have this network in France, the JPAN, that really look into all the UAP phenomenon. I'm not sure actually. I think it's maybe the same. I mean, I've been interested into the question when I was still living in France, and I don't know if Jacob, do you have any idea on that subject? I know you had a lot of French people from the aviation side, and also some scientists are working in some international team on the question of UAP, but I'm not sure there is a fundamental difference into the way we approach that.
Yeah, I'm not sure. I mean, it's a great question about what the cultural differences are. I mean, my understanding is that the actual sighting of aerial phenomena that are unexplained by military pilots and commercial pilots is a global phenomenon. But how the sort of cultural interpretation of those facts is represented in different nations, I don't know. Actually, I'm more familiar with the United States.
What my interest here is that ultimately what I'm getting at is that, okay, so we have Congress here in the U.S., Jacob, where they're looking into the UAP and asking the Pentagon questions about actual hard data they seem to have. I mean, they seem to have radar contacts and things that we could look at if they weren't classified. So my question is what about France? France operates a nuclear aircraft carrier group like we do, and what are their observations? And would it be helpful? Let me ask you this. Would it be helpful to have a multinational probe into what everyone is seeing collectively to try to determine what it is and if there's anything there that's of astrobiological interest?
Oh yeah, absolutely. I mean, I think there are some new efforts now to try to really have some coordination on the international scale. But yeah, definitely. I mean, we really need data and good quality of data, and for that we need to be able to share them. And so yeah, we're totally in favor on about that. Yeah.
In regards to the stigma, the taboo on the subject, which I'm openly tossing off, admittedly, do either of you have any misgivings or fears within the scientific community as members of it, of even talking about the concept of close alien life?
At first, I was a little bit, just cautious about how I wanted to talk about the idea of UAP, UFOs in general. And that's when, Ravi Koparapu and I published the Scientific American article. We sat on it about a year before we felt the timing was right and ran it by our colleagues and bosses. And that was about the time when the Navy videos were declassified. And so it seemed like the timing was right to try to start talking about this more. I feel like that has been successful. Everyone who's been talking about it has helped to reduce the taboo. So when I go to scientific meetings now, a lot of my colleagues aren't personally interested in UAP still, but they're open to the idea that it is a scientific problem. I think the culture has changed a lot in that respect. And then also for solar system SETI, even totally separate from UAP, just I think having a new generation of scientists come in, taking the idea of technosignatures seriously. We have a whole host of Mars missions and other solar system exploration. We have private money coming into technosignatures. So I think the idea of looking in the solar system is more amenable among scientists today too, just for a lot of cultural reasons.
Yeah, absolutely. The mentality are also really evolving. Like if we think about even a biosignature, like, a decade ago or more, it was not really mainstream. Now it's totally is. And then a few years ago, the technosignature research was also not really mainstream. Now it is. So I think, yeah, we basically keep, we have to continue to talk about it, to make some really, rigorous research and looking for data, and that eventually, will change as well.
Now, I mention this because decades ago, a scientist, an atmospheric scientist named James McDonald looked into this, and he felt ultimately that an alien origin for some of the UAP accounts, and it's important to say accounts because that's not very good data, but he felt that the alien hypothesis was the least worst hypothesis. Was that premature on McDonald's part? I mean, can you really work? I guess what I'm asking is, can you really work from witness accounts and actually come to any kind of solid conclusion? Or do you need real data? And what would we do in regards, especially let's take the Galileo project and Dr. Avi Loeb, what would we do to actually get real evidence to where we could make a determination if there are aliens in our solar system with us and, for that matter, our atmosphere?
Right. Yeah. Great question. So I guess for James McDonald, I really like James McDonald. His paper Science and Default gives a great model for how to explore UAP from a scientist. He does rely heavily on eyewitness accounts, and there is limitations as to what you can do with that. And I think that's just what he had available. And I think he was probably a little premature in jumping to the extraterrestrial hypothesis. I think we really just need to collect more data at this time. But to your point, yeah, I think what the Galileo project is doing is fundamentally the right thing. We can't rely on getting more declassified data. We can't rely on any prior sightings. The data it's very scant. Like you say, a lot of it relies on eyewitness testimony. So you need new data that's collected in a systematic way, the way you do a scientific experiment. And so, the Galileo project is building a network of sensors that it's a multi-sensor array that's looking at optical and infrared wavelengths and capturing sound and capturing other properties about the weather and other things about the environment, sensing the whole sky across many points, so that if there is an object, known or unknown, that crosses the field of view, you're capturing that and you're identifying it, or you're flagging it as something that is unidentified. Now, if you start to find things you don't identify, well, this is where it is very similar to the search for life and technosignatures. Even if UAP has nothing to do with aliens and it's just something unknown, it doesn't really matter at that point, because if you find something in the sky that you can't identify, but you've ruled out airplanes and you've ruled out birds and you've ruled out aurora and everything else, maybe you found aliens, but whatever it is, you have to then dig a lot deeper. You have to ask new questions and conduct new experiments and analyze the data even more to figure out what you can learn about this. And so in the same way, if we looked at TRAPPIST-1e with the James Webb Space Telescope, and we saw something and it looks like atmospheric pollution in the atmosphere, well, that'd be great. I'd be super excited. Maybe we found a technosignature. But we're also going to have to then play the long game about trying to break our hypothesis. And are there other ways we can explain that data? Are we really missing something? And so, if the Galileo project finds some anomalies, that's going to be really exciting. But then that's not the end. That's actually the beginning. That tells you what else do we need to learn to actually understand what these things are. And if it turns out that it's extraterrestrial, great. I'm the first one to celebrate. But it doesn't end by just saying there's things we can't understand. You have to understand them and then convince yourself somehow about what it is you're looking at.
I think it would be really sad if we looked at an exoplanet and saw an obvious technosignature like CFCs in the atmosphere, but they weren't for terraforming purposes. They were just messing their atmosphere up and destroying their ozone layer. We're like, whoa, the first alien detection is really sad. They're destroying their world. Although it could.
Although, you know what? It would actually be okay, because if they were doing that, the odds of us observing an alien civilization in that instant right before they go extinct is really small. We're probably going to catch the long-lived aliens that are, whatever they've been doing, they're able to do it for a while. So if they've got CFCs in the atmosphere and they're just living there, it means they figured out a way to make it work. And then it's not so bad for us. Maybe we can figure out a way.
Yeah, that will be super interesting, because that will also mean that life has, follow the same path, and so that they are also going to their own, pollution of the atmosphere, and that would be actually very interesting.
Well, what would be really interesting is if we saw some megastructure like a Dyson sphere or something that stretches and blurs into science fiction, that says alien civilizations last indefinitely, and therefore our chances of lasting indefinitely are great. So the bigger the technosignature you see, higher up on the Kardashev scale, the more interesting it is, because it suggests that at least someone survived long enough to do unbelievably advanced things, right?
Right.
Yeah, absolutely. That's the very interesting thing about technosignature. They can be almost anything, and they are likely less ambiguous than the biosignatures. And they can also, as you said, they can remain after the end of a civilization. Like for biosignature, once life is gone on the atmosphere of a planet on a surface, the biosignatures are going to be gone very quickly. When technosignatures can really remain far after the end of a civilization, like technology can stay there for a while. And so that's always the very open question right now. Is it, easier to detect first biosignature or technosignature? Maybe we think before going to technology, you need to first start as a biology, and so maybe there are way more biosignature across the universe, but their signature is probably much more ambiguous and again maybe much more short-lived by comparison to technosignatures.
Individual assessments from two scientists, both of you. What do you think the chances are of the object, the mysterious object Oumuamua, to have actually been something of alien origin? Do you think we're in that territory, or do you think that it was just a weird rock and we should probably not pay too much attention to it and look for future objects?
Yeah, for me, no, it's not. It's absolutely not a mothership. There is no way. That was like, having some interstellar object crossing the solar system was absolutely expected as a natural, phenomenon. The direction where it comes from was also expected, and as many papers have really, demonstrated that it's absolutely not an alien spacecraft.
So yeah, I agree with Thomas. I don't think it's an alien spacecraft. Now, my understanding is that the size of Oumuamua was smaller than what was expected for the first interstellar object we were supposed to see. And I think that's really interesting because I think it's a totally valid question to ask, are there interstellar artifacts that are technosignatures? And if we want to look for artifacts in the solar system, you have to understand what the background of other non-technological objects coming in and out of the solar system is. So I think Oumuamua is in the second category. It's probably just a rock that came into the solar system, but it didn't seem to match all the theories about what we would expect. And so that we need to understand better how interplanetary exchange of objects occurs, or interstellar exchange of matter occurs. Because the better we have theories for what the frequency of Oumuamua-like objects should be, the better we're going to be able to pick out technological artifacts if they're there.
Now, searching for far technosignatures, you guys recently released a paper on low-mass stars and how they might be perhaps targets for alien civilizations that are advanced and spacefaring to go and colonize. Lay that out for me.
Sure. So this is the classic Fermi paradox, where hypothetically, I don't even know if Fermi really asked this question, but the story goes, Fermi was asking, if life is common out there, where is everybody? It wouldn't take very long for one civilization to send out two settlement plan, two sets of settlers to go to other star systems, and those two send two out. And if you do that, you could settle the whole galaxy really quickly. And Michael Hart wrote kind of the seminal paper about this, where he just kind of does a back of the envelope calculation and says, look, you could settle the whole galaxy in about 2 million years, traveling at 10% the speed of light. So the fact that we don't see any evidence of aliens visiting the solar system, that means that we're probably alone, or just expansion doesn't happen, and you just don't. If there's life out there, if there's civilizations out there, they just don't expand, because it wouldn't be hard from that point of view with exponential growth and the time scales that we're talking. Not very hard. So where are they? That's the fundamental question. So that's where we come in, and there's lots and lots of explanations to the Fermi paradox, and so I'll just start up by saying, these are fun discussions. The Fermi paradox is supposed to be thought-provoking, and I'm not saying that this is the only answer, and all the other 200 published versions are these are all just fun ways to think about how can we explain the fact that we don't seem to see any obvious evidence of a galactic empire or something that has been through the solar system. And so in this paper, we point to some work that Bradley Hansen and his colleagues had done, where they point out that over long, and we learned this in astronomy, over long time periods, stars move. It doesn't seem like it when you look at the sky every night, but the stars do move over millions, thousands and tens of thousands and hundreds of thousands of years. The stars move. And so if you're a patient civilization, which is what Brad Hansen pointed out, you could wait a long time to migrate to another star. And so right now, it might be a few light years away to the nearest star system. But if we were to wait, several, tens of millions of years, that distance would decrease, and you would only have to go, not even a full light year to get to the next star, because you just waited for a star to drift closer toward you. And so we just kind of extend that further toward looking at the Fermi paradox and say, okay, if you can be patient and use patience as a strategy for galactic settlement, well, then you can actually do exactly what Fermi and Michael Hart suggested. You can, get to all the stars, especially the low mass ones, in a very short time period. But it doesn't require the sort of relativistic space flight of even getting close to the light speed. You just kind of hang out and wait to send your expeditions until the stars get close. And so if you do that, you can kind of patiently explore the whole galaxy and still get to, all the stars. And so if they're all going to low mass stars, well, that would explain why we haven't seen them. We're a yellow G dwarf star. And if they're all going to red dwarf stars, that would explain why we don't see them coming into the solar system.
The sun is uninteresting to alien civilizations looking for longevity in their star. Stellar encounters as a method of colonizing the galaxy. So you wait around and red dwarf passes, so you put a probe there or a civilization there or whatever, an off branch. And you do that. Now, over the course of the sun's history, the 4.5 billion year history, how many stars has it encountered roughly close by within, say, 3 light years?
That's a good question. Do you know, Jacob? I know, that definitely has several have, passed nearby, but I have no idea in about the number, actually.
Yeah, I would have to calculate that. I mean, we have a formula in the paper to calculate exactly what you're asking, but I just don't remember the relationship, because it definitely depends on that distance. Are you able to travel out 3 light years or 10 or however many? And the number of close encounters you get varies as a function of that distance. So I'll refer you to the equation in the paper.
The number is probably enormous, though, right?
Yes.
I mean, can we say that much?
Over the lifetime of the sun, there's definitely numerous, especially if you're going out beyond 1 light year. Then there's going to be dozens to hundreds, if not thousands, or more of opportunities.
Yeah, and the sun has been formed in the same, probably the same nebula and the surrounding stars. And so at that time, the proximity may have been also much higher. And what we really have tried to do with this paper is a sort of if I can do an analogy with quantum physics, it's like an optimization of the mean free path, basically, to say, okay, if we have to really wait when it's perfectly optimized to make that travel, because it's probably journeys through space are not trivial, and so we can tend to think that extraterrestrial civilization would like to optimize that.
So does it seem weird? Another question to both of you. Does it seem weird that we see a great silence? I mean, do you agree with the notion that we really shouldn't? We should see them everywhere, and we should see them perhaps here. Does the great silence bother you in that respect, that there really doesn't seem to be any prohibition against aliens? We're an example. We're someone else's alien civilization. Does it seem weird that we see the great silence and that aliens aren't obvious?
I don't know. And do they want to communicate? That's also the thing. I mean, maybe they just want to stay hidden. That's so. Is that question that I'm wondering? I think we don't know even ourselves. If we make our position obvious, are we going to have a civilization that has more like predatory way, and that would be really bad for us? And I mean, maybe every single civilization out there think the same. You always have a bigger fish, and so maybe the wise things to do is not to give up your position, or so at least on a passive way, really trying to mitigate anything we release, and then if one of them want to communicate, it would likely be something like they intended specifically in a specific direction. At least in my opinion.
Yeah, I mean, I think I guess a couple thoughts. One is when I think of our idea, I like this solution to the Fermi paradox as a way of kind of dealing with that great silence. At least the idea of why are we not obviously visited in a way that we would be very convinced without having to do all this extra work. Why does it seem like we're not part of this galactic empire? And so if the civilizations that really last for astronomical time periods are engaged in sort of this slow, methodical exploration, settlement of the galaxy, it sort of makes me think of like, our life on Earth started, we don't know exactly where, but maybe in hydrothermal vents, maybe in, swampy anaerobic areas, something like that. Or G dwarfs, like, the swamp, and we're crawling out of the swamp, and then life kind of moves on to other star systems. And, we're not really interested, in going to hydrothermal vents to build our civilizations. And so maybe, G dwarf systems are great for getting life started, just like hydrothermal vents may be great for getting life started. But then, then it moves on, and you don't need to hang out in a hydrothermal vent. And so, maybe that's an exciting answer to the great silence, is that it's not silent. We just happen to be in sort of the hydrothermal vent of the galaxy. This is just where things get going, and then it moves on later. But I'll also say that I don't think we've looked enough yet. I think we can only rule out very specific versions of the Galactic Club hypothesis. There's not loud omnidirectional radio beacons going on at all times of the day everywhere. That's all we can rule out. Even breakthrough listen can only listen to each star for a couple seconds at a time until you might have missed an important transmission that's coming. So I think with radio and with other types of technosignatures, we're just barely scratching the surface. So I don't think we can actually rule out very much at all. And so with our paper, what I'm hoping is that, I'm interested in from a biosignature and just planetary habitability point of view, also in just the discovery and characterization of these low mass planets, Earth-sized planets around low mass red dwarf stars. So wouldn't it be great if we're studying these planets and it just so happens that that's the best place to look for technosignatures, not because they're the best place for life to evolve, but it's the best place for life to move once it's evolved? That would be really exciting. So I hope it's true. I don't know what the likelihood is, but it certainly would be a fun solution.
The question of us. All right, we are a civilization, and as I said, we are somebody else's alien civilization. So how easily are we detected? Because that might shed light on just how hard it is for alien civilizations to discover each other. So if you're an alien civilization 10 light years away and you look at this star system and you say to yourself, well, G-type stars tend to spawn life perhaps. And you look here, what would you see? Are we detectable as an alien civilization to others?
Well, yeah, there are several ways, right? I mean, we broadcast radio emission for like 100 years or so. But also like simply doing that, as what Jacob and I do for exoplanets, is just looking at the spectrum of Earth and the sign that into Earth atmosphere. And when, we will imagine for them, because we are orbiting a G star, we are not going to really do transmission spectroscopy, which is not really optimized for planet orbiting such kind of star, but instead we may be going to think about direct imaging, and also that means that really see Earth as a pale blue dot orbiting the sun, and then making an analysis of the color of the light that is reflected by the Earth atmosphere. And from that, we will definitely pick up things like ozone, oxygen, methane, and also technosignatures, as we have said, like CFCs and things like that. And so, yeah, if we are like 10 parsec away when we are looking back to Earth, with a future direct imaging mission like IRUV or LUVEX, depending on how you will call it, but that the NASA 2020 Decadal survey has basically recommended for around 2040, then we will definitely have the capability to observe that. So yeah.
Off the wall question. There is an elephant in the room. The closest star system to us, obviously, is Alpha Centauri, and which includes Proxima Centauri, which is a low-mass red dwarf orbiting two sun-like stars. And is this a good place to look? Or statistically speaking, is it a bad place to look because it's simply too close? Because if we had an alien civilization right next door, that would imply perhaps that there are alien civilizations everywhere, and we should see that everywhere. So is that the place to start? That close?
It's a fine enough place to look. Like, given the hypothesis we're proposing in this paper, if we're saying M-dwarf stars are good places for civilizations to migrate, then sure, I think it's worth looking. I think Proxima Centauri b, from what I know, is probably not going to be the most habitable planet compared to some of the other cases. Maybe TRAPPIST-1e is a better case. I mean, again, we should study all of these planets because we can be surprised. All we can do is guess right now with our models what they're probably going to be like. Of course, if you're really close into the star, you're probably going to be too hot. If you're really far away, it might be hard to get an atmosphere that's not frozen. But we're just barely starting to study extrasolar planetary systems and just scratching the surface of getting data from their atmospheres. So, yeah, I mean, Proxima Centauri b is not my favorite target, but it's close by. We should study it. Maybe we'll get surprised. That would be amazing.
Yeah, absolutely. I agree with Jacob. I mean, of course, there is this project, the Starshot, initiative that will possibly be able to send some probe there. So that will be really interested. But yeah, I'm not super optimistic about Proxima Centauri b because like the star Proxima Centauri is very active. You have a lot of flares, extremely powerful, and there is absolutely no way with anything we know about planetary atmospheres that any atmosphere can survive around that kind of star. And even if you consider the strongest, unrealistic possible fluxes from the interior of the planet that will be able to replenish the atmosphere, it will not be enough. So if there is an atmosphere on that planet, that means that really all our atmospheric models are wrong.
Now, when we look for technosignatures, we tend to look for what we know, things that our civilization produces, such as radio signals. But is it perhaps more likely that we will stumble into the discovery by finding something incomprehensible that we don't understand, that appears technological, that we don't do, that we don't recognize as either natural or something that we as humans do, but something in the far future that we might do? Do you think that a serendipitous discovery of alien life is possible that will just completely surprise us and take us off guard?
Yeah.
I mean, one of the...
Go ahead.
So, yeah. Well, one of the big things I worry at work is like we may have already observed life either for like biosignature or technosignature, but we were not able to recognize it as such because if it's something really different from what we expect, if we don't have any comparison point, we may completely miss it. And so we may already have observed a lot of timed life around the universe and just not have identified that as life.
Yeah, I fully agree with that. I mean, it's possible that Breakthrough Listen has already recorded a message, from extraterrestrials that was beamed toward us, and we just didn't know how to analyze it, right? And it's sitting on a hard drive somewhere. Or another thing we think about is maybe it'll be the first anomalous sign that's associated with alien activity is someone who's not doing astrobiology at all, and they just find this signal in their data set where they're just doing something totally decoupled from astrobiology. So there's lots of examples in science of things like that. So totally possible.
Exactly, specifically on exoplanets, right? The first exoplanet has been discovered in 1991, whereby a scientist looking at pulsars. And so it was really not, anyone searching for exoplanet, but that was the first discovery of any world outside the solar system.
Wow signals and transients. In other words, we don't see sustained alien signals. We just see things like the wow signal where we're left wondering and scratching our heads as to what exactly it was. Do we have much of a chance of detecting alien life unequivocally just simply by picking up weird transients that look technological and we can't explain? In other words, can there be a self-contained, non-repeating SETI signal that we could say, for sure, this is proof of alien life, but we only saw it once?
That's difficult. Transients are hard because in many cases, with science, you like to be able to have things that repeat. But there are things that we study in science that don't repeat. There are fast gamma ray bursts or fast radio bursts, and there are supernovae and other things in astronomy alone. So of course, something like the wow signal just has it's too ambiguous to be able to say for sure what it is, that it's not some unexplained radio frequency interference. But if you were to get some hypothetical transient signal and it had really high information content, it had all the prime numbers, and you just received it once, I mean, that would be a really good candidate. So I think it just depends on the character of the signal.
Yeah, every measurement in any field of science has always, an uncertainty associated to it. And as long as we are good enough, to estimate correctly the confidence level of what we have observed, then I think we will be good. But that's the challenge, is to make the correct assessments of the confidence level of the signal we detect.
Now, I want to point out here, for anybody interested in the two recent papers, there's links in the description below to both of them. Here's what worries me. Okay, so we look for close alien artifacts. We look for objects in the solar system or the atmosphere, close aliens. Does that immediately mean that the zoo hypothesis is the correct solution to the Fermi paradox? Because whenever you have a close alien civilization that's more advanced than you are, it's in control.
So you're saying if we find artifacts, then that means we're the zoo animal.
Yeah, because by virtue of if you found a dead artifact, a real artifact of a civilization that was here billions of years ago but no longer is, you're still left wondering about the spooky question of where did it go? Where are they now? But if you found active artifacts, that basically means we're curated, right? By virtue of their superior technology.
Yeah, I mean, on one hand, right. So in astronomy, things that are short-lived don't stick around usually to be observed for any length of time. So if we're seeing active probes in the solar system, then whoever's on the other end of that has probably been around a lot longer than us. So how you interpret that, that's an exercise in science fiction, but certainly we're not doing that. We're just barely thinking about interstellar probes. So if we find that we've got interstellar probes here from someone far away, they're definitely more advanced than us. And what does that mean is a big question.
Yeah, I have not really anything, to add to that. It's very difficult. Like, they can indeed let a beacon, but and not have, and just have left have been, not very interesting to us as well. It's very hard when we start to think about then psychology and how they will think by comparison to us. It's really a lot into the science fiction and the metaphysics for me. Yeah.
I guess one thing I would add is we still don't know what they're interested in. There might be probes in the solar system because you want to study G-dwarf stars because that's where life starts, and their scientists wanted to study habitable planets. Maybe they're mining bots and they came to mine the asteroids and they don't care about squishy life on Earth. We're just something that happens to be in the neighborhood. So it's totally possible that the life is common in the galaxy. It's spread across all the low mass stars, and they don't care about us. We're like ants or like bacteria or something. We just exist and they just ignore us. We're of no interest. So that's totally possible.
Yeah, and if there is indeed a galactic club, maybe there is a sort of convention, or don't go to a stellar system where life is already there. We don't know.
Now, to evoke the aforementioned Adam Frank, and also Jason Wright for that matter, prior technological civilizations on Earth, could that possibility that we can't rule that out, that there may have been someone here before us that were Earth life as well, since we can't rule that out, does that make it impossible to actually determine if a close alien artifact is actually alien or if it's originally from Earth? In other words, we find some object or make contact with something that's close by within the solar system with us. Given that you can make genetics look like anything you want, you can customize them as far as a future technology goes, or you can change isotopes in metals and make it whatever makeup you want. Is it possible that we could be in a position of finding an alien artifact and never being able to prove, say it's a frozen body from Roswell, and never being able to prove that it's actually a separate abiogenesis from another exoplanet as opposed to Earth life that's simply obscured, hidden, and changed?
I like the way you asked that question because it actually highlights an important part of how science works. In science, you really don't prove anything. And as much as some people get upset about that, you don't really prove things. What you do actually a lot in science is you disprove things or you falsify things. You come up with a hypothesis and then you try to break it. And if you break it, then you learn something in the process and you come up with a better idea and then you try to break that idea. And so in that sense, whether we're talking about artifacts in the solar system UFOs, whatever they are, or technology in the exoplanet atmosphere. What we're doing in all of those cases is we're always going to be playing this game of like, yeah, you think it's technology, but what else could it really be? What else could it really be? And so, especially since concluding that it's a technosignature is sort of the most, it's the most far-fetched explanation, or it's the most unlikely given a lot of the context we have. You're going to spend a lot of time trying to break that hypothesis and show that it's not true. So what you're going to end up with, if it really is a technosignature, you're just going to have time after time after time you try to explain the data in another way. You're like, oh, well, it's not a technosignature because of this. And then you do that investigation and realize it falls short. And so you're kind of always left with the tentative conclusion that, like, given all the science we've done, this is what we know. So yeah, you'll never really prove it, but you might have really convincing evidence that there's no other explanation.
Yeah, what we do is really a search for anomalies. It's a word. It's really a key word here that Jacob also has said earlier. And of course the more the anomalies will be very different, very far from what we expected and what we know, it will be just more obvious to us. But maybe you will have some anomalies that are a bit ambiguous. But overall, for technosignatures, for biosignatures, for UAP, all we are looking for is anomalies. And indeed, as Jacob said, and we put some hypotheses to try to explain them.
Now, my last question for you guys is really off the wall, but I'll ask it anyway. Now, your countryman, Thomas, Jacques Vallée, has floated that maybe, along with J. Allen Hynek, that maybe the UAP phenomenon might be weirder than aliens, and that it is perhaps, based on the accounts, again, not very good evidence, but based on the accounts, that it might be even weirder than aliens, unknown science, something dealing with dimensions or something like that. Do you think that sort of reasoning has any legs at all, or should we stick solidly within known science as a philosophy in looking into this, as opposed to asking questions about maybe there's unknown physics here that these things might be taking advantage of?
Yeah, I mean, it sounds very science fiction to me, but again, we should not have any taboo, and so I would say, why not? It has to not. It has to be on the table, but of course, again, we have after to rank what seems to be, the easiest possibility. I don't know if the Docam razor it's something we want to bring here, but yeah, I don't think we need to exclude anything.
Yeah, I think we should certainly not be afraid to entertain any hypothesis. When I hear, explanations for, UFOs invoking, that there's something interdimensional going on, it's a little hand wavy, and maybe that's just shorthand for something crazy that we can't explain. And that's fine. One thing I noticed when I started first getting interested in, the UFO phenomenon and what's really going on here, there seems to be multiple things that get grouped under UFO, under the heading. And there's a category of observations that are things that pilots have seen, that aviation associations are now interested in, and that seems to be what the military is studying and what the Galileo project is focusing on. Some of these other accounts seem to have more to do with out-of-body experiences, or they have abduction components to them, or some other sort of hallucinatory component that, to me, is also a really interesting question. It may have more to do with understanding psychology and sociology and some other disciplines. I think that's a separate topic. And I think sometimes the two things get conflated. And so, like, is there something else to that? What are out-of-body experiences? I think that's a great scientific question. But I think that's actually pretty different than what are the things that fighter pilots are seeing that are also showing up on radar that we can't observe. So I think we just have to be careful to not conflate hypotheses, and at least until there's a reason to decide that there is a relationship with them. And so I think with UFOs and other technosignature discussions, even in among non-scientists, you can sometimes conflate hypotheses where there's not necessarily an obvious link yet.
I would dearly love it if we got a radio signal that we could actually decode from an alien civilization, and the question they asked us is, what do you guys think the UFOs are?
Unidentified.
So to end this, what are the chances? What do you guys think? Do you think within our lifetime we will actually be able to say that alien life probably exists, or do you think it'll still be an open question 500 years from now?
All I can tell you is I hope we have an answer by the time I'm old, but I don't know what the likelihood is.
Yeah.
But if we don't look, the likelihood is zero.
Yeah, exactly. Same for me. I hope. I hope I will see that. I mean, I'm 35 years old, so I think we still have time. But yeah, it's definitely either from the solar system or beyond. Yeah.
I'm hopeful that within my lifetime. Now I'm 47, but within my lifetime that. Well, we may not see a SETI signal or anything like that, but maybe we will crack the chemical process of abiogenesis, and from that we could say this is either easy or it's hard, and we could just do it from that perspective, and that the alien life question will simply be answered by this process is a lot easier than we thought, so life must be everywhere. So that's my hope.
Yeah, even if we have really, we have searched very hard for super long time, and we still have not found anything, that would be interesting as well. I mean, the universe is very, very, very vast. So maybe even, few decades from now, we will not have searched enough. But nevertheless, we will have been through a lot of different instrument techniques and approach, and we will be able to rule out some of the hypotheses in some of the cases, and it would be very interesting.
All right, gentlemen, thank you for joining us today. And again, as I mentioned, the links to the recent papers is in the description below. And I hope sometime we'll check in again when you guys release another paper.
Absolutely.
Yeah, thanks so much for having us.
Thank you very much.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice. What a really great interview. Hey Aaron, have you ever wondered if alternate universes exist?
No, not really. You can't ever prove it. Does it even matter anyway?
Yeah, probably not, I know, but I just can't shake the feeling that there might be more to this. Like I might be in the wrong reality, or the right one.
Well, you could have fooled me. Anyway, have you sent my check out yet?
Wait a minute. It was an alternate reality. The possum has gained control over the many worlds interpretation of quantum mechanics.
Yes, John. And it seems one of my iterations actually gets paid.
Yeah, none of mine do.